Welcome student. Now today we'll discuss on case hardening process, and it is very important heat treatment process. And in the previous lecture video already discussed on the different types of heat treatment like annealing, normalizing, quenching, hot tempering, hot tempering. We already discussed on this all these topics of heat treatment process. Now today we'll discuss on case hardening. Now case hardening is something different with the other heat treatment process, and as you know that case hardening. So what is the difference between that annealing, normalizing, quenching, hardening, tempering, post-tempering, tempering process with case hardening? The main difference is that for all these processes like annealing, normalizing, and all these processes is basically used to improve the mechanical properties, uh, for the entire metal. But in case of case hardening, the heat treatment process is basically used to increase the or to improve the mechanical properties within the in the outer surface of the material and to retain the softness of the core. Okay, softness of the core. So this is the basic difference in between case hardening and in between and handling, normalizing, water quenching, tempering, tempering, or tempering processes. Now, as the name suggests, the case hardening process. Now, case hardening basically used to increase the hardness or to increase the strength to improve the mechanical properties for the outer surface only. But in case of other heat treatment process, is basically used for the to improve the mechanical properties for the entire metal. So the basic difference. Now go to the next. In the next picture. So this is the case hardening. Now case hardening is basically used as the name suggests. It's hardened. It's a hardening, and it's basically done in the case sections, means outer sections. Okay, and the case hardening in basically it done by four processes. That is basically the case carbonizing, cyaniding, nitriding, and flame hardening. So these are the four processes you can done your case hardening process by among of them. Okay, depending on your condition, depending on your applications, you can use one of them. Now, first we will discuss on case carbonizing. Now, case carbonizing is basically used for the low carbon steel. So, basically used for the low carbon steel, and in the so it is basically used for low carbon steel. And in case of case carbonizing, the material that basically used, that is basically charcoal. Charcoal are basically used for carbonizing part, for case carbonizing. Now it is basically used for low carbon because of, as you know, that in case of quenching process, in quenching process the main phase that present, that basically martensite or benite, but that martensite and that benite basically actually is hard and brittle in nature, and it is not done carried out easily in case of low quenching process for low carbon steel. But when you move to the other case hardening process, like for low carbon steel, it is easily possible. So that's why it is possible for carried out for low carbon steel for case carbonizing. Again, and basically the material which is basically used, that is basically charcoal for case carbonizing. Now, what is the process for case carbonizing? As you know that for case carbonizing, suppose this is the container. Okay, so this is the container in which the charcoal and the specimen you want to just case carbonizing process takes place. So suppose this is the specimen you want to do the case carbonizing process. Now if you keep the material within the container where the charcoal is already up there. Okay, so it is a mixture of charcoal as well as specimen. Now it is kept within the furnace. So this is a furnace. Within the furnace you just kept, so you kept the container with the charcoal plus specimen within the furnace. Then the temperature which is basically cold or heated in the furnace, the temperature is around 800 to 950 degrees Celsius for the time required, that is basically 4 to 20 hours. Okay, 4 to 20 hours. Now when in the container the present oxygen, there are some present oxygens. So the present oxygens basically they react with present charcoal within the container and they form basically carbon monoxide. Now this carbon monoxide is basically contact with the specimen, they basically release oxygen. Okay, oxygen, and when they release oxygen, while carbon diffuses into the outer skin of the specimen, because main objective is that to improve the hardness of the material for the outer sections. And as you know that uh, for suppose this is the carbon content. Just a minute. So as you know, so this is the percentage of carbon and this is the percentage of hardness value. If you increase the carbon content, you already know that if the percentage of carbon is increased, the hardness value will be increased also. So in case carbonizing process, after getting the specimen with contact with the carbon monoxide, they release oxygens while the carbon diffuse into the outer skin of the specimen. So basically, they are basically form the layer of carbon in the outer section of the material, and they can produce basically the carbon layer. So this basically carbonizing process, and they basically give you the maximum amount of hardness from the material. So this is the basic process of case carbonizing process. And in case of gas carbonizing, also one type of gas carbonizing. Gas carbonizing also one type of carbonizing process where the carbonizing material and basically carbon material which is basically used, that is not charcoal here, that is basically used basically natural gas, and that natural gas basically used instead of charcoal actually, and natural gas like methane, propane, like this type of natural gas basically used for gas in case of gas carbonizing. Okay, and it is basically similar to the pack carbonizing. And one more thing that main advantage of is that the better control of surface carbon and the case depth. So this is the basic advantage over case carbonizing process. And one more thing that case carbonizing also sometimes also called pack carbonizing. So all these things, so these phenomena basically when you use the charcoal, that sometimes also called pack carbonizing, and when you use for carbonizing process instead of charcoal, that is basically called gas carbonizing. Okay. So in pack carbonizing, main element that basically used, that is basically charcoal, and in case of gas carbonizing, that is basically natural gas. So in whole process, in case carbonizing, so there are main two way you can get your to improve the mechanical properties of material by heat treatment process. One is pack carbonizing, another is gas carbonizing. When the natural gas is used, that natural gas may be methane, propane, like this type of natural gas, and in case of pack carbonizing, charcoal basically used. But if you compare in between gas carbonizing with pack carbonizing, most efficient is basically in case of gas carbonizing because of better control properties, surface property you can get through gas carbonizing process. Now, if you draw a diagram, or as you know that depending on your case depth with carbonizing time, as you see that in this diagram, these x-axis basically indicate that carbonizing time in hours. So basically from 0 to 40 hours like that, and in y-axis, as you see that this is the case depth. So this case depth basically indicates the amount of carbon that layer within the outer surface of the material. So if you go on beyond, if you increase the time, if you increase the carbonizing time, so obviously case depth is increasing. So in this plot you can see that those this is the carbonizing time plot and this is the case depth. As the time progresses, the case depth also progresses. Okay. Cyanide. Cyanide is basically important case hardening process. As we discussed that case carbonizing. In case of case carbonizing, basically there are two types of case carbonizing, as you know, that pack carbonizing as well as gas carbonizing. Now, cyaniding. Now, in case of cyaniding, it is sometimes also called liquid carbon nitriding. So, because of there are carbon and nitrogen, both are basically used to increase the outer surface of the material, of the hardness. So that's why it is sometimes also called liquid carbon nitride. And why it is liquid? Liquid is because of the carbon and nitrogen both are in liquid in conditions. So that's why it is called liquid carbon nitride. Okay, so cyaniding is sometimes also called liquid carbon nitride. Now, basically, it's basically addition of carbon and nitrogen. Both are basically used for additions. But now, what is the process for cyaniding process? First of all, the heating the steel in molten bath of cyanide, and where basically it is also mixture with some type of sodium chloride. Okay, sodium chloride. So it is basically heating the steel in molten bath of cyanide, and sodium chloride some amount of also used because to increase the fluidity of cyanide. So that's why sodium chloride are used with cyanide. Now that steel, heating the steel in a molten bath in cyanide plus sodium chloride. Now temperature as it is heated, that is basically temperature is 750 to 850 degrees Celsius. Now the contact basically contact with the material, that is basically for 30 to 60 minutes. Okay. Now case depth that can be achieved through cyaniding process, that is basically 0.15 millimeter. Now basically after when it complete the cyaniding process, and after cyaniding process, basically that is basically quenched. The material is basically still is basically quenched in either oil or water. And one more important point is that it is basically faster process compared to the case carburizing process. Okay. So night is important case hardening process. So as you know that case hardening process, basically in four ways you can do that case hardening process, like case carburizing, cyanide, and night hardening. We discuss on night hardening. Already discussed on case carburizing and cyanide. Now night hardening. Night hardening, basically in night hardening process. Uh, so this is the night hardening process. So in night hardening process, we basically used ammonia gas. In case of case carburizing or pack carburizing, we use basically charcoal. In case of gas carburizing, we use methane, propane, as well as liquid cyaniding process basically used that sodium cyanide, potassium cyanide. So this type of material, this type of solutions we can use basically for cyaniding materials. Now, as you know that for alloying element, it is basically used that where it is used, that basically used for alloying element of steel. So alloying element steel, we already know that what is steel. So steel is basically a combination of ferrous and carbon. So this is basically plain carbon steel, and alloy steel is basically that type of steel in which the main alloying element means ferrous and carbon. Obviously they will be present, but there are other alloying element can be added, like chromium, vanadium, sulfur, phosphorus. This type of alloying element can be added. Like you can say that chromium, vanadium, aluminum, if it is present within the alloy steel, and if ammonia also present, ammonia gas also present, so they will react with other, and they will form a very hard nitride, which is basically formed with the outer surface of the layer. Okay. Now what is the process for the nitriding process? As you see, suppose this is a container. So this is a container. So this is a container in which the ammonia gas is contained. And as you know that basically you know that quenching process as well as tempering process. Now after quenching and after tempering process, that steel is basically called quench and tempered steel. So that quench and tempered steel now is basically mixed up with ammonia gas in a container, and they kept in a furnace. Suppose they kept in a furnace. So they kept in a furnace, and for the temperature range of 500 to 575 degrees Celsius around, and time is basically kept for 8 to 40 hours. Okay. And when you do that, it's basically form a nitride, a very hard nitride with the outer surface of the materials. So this is a hard surface layer of the material, and they can produce high amount of hardness. Okay. And this is a basically nitriding process. And as you know that there is no possibilities, and there is no require, actually there is no require for quenching process after nitriding process, because quenching process is needed as in case of case carburizing or any type of pack carburizing processes. But in case of nitriding, there is no as such quenching process is required. So this is the main difference, and there is less possibilities and of distortion and deformation, because of, as you know, the temperature range for nitriding process is 500 to 575 degrees Celsius. But whereas case carburizing, pack carburizing process, as you know that the temperature is around 8 to 875 degrees Celsius. The temperature is range is very important when in context of nitriding process. So less possibilities of distortion and deformation, because no quenching process is needed after nitriding process. Okay. Flame hardening. So flame hardening is one type of important heat treatment process of case hardening. Now, as you know that the name suggests that flame hardening. So there are some flame that are basically used for flame hardening process, and that flame which are basically used like for flame hardening is that oxyacetylene gas. Okay, oxyacetylene gas flame or oxyacetylene flame are basically used for flame hardening. First point. Second point is that where it is suitable. Now, suitable for carbon percentage where the 0.3% to 0.6%. In all these types of steel, you can use your flame hardening or case hardening process. Now, suitable for carbon percentage where carbon percentage is 0.3 to 0.6. that doesn't mean that you cannot use that like for high carbon steel. You can use your high carbon steel in case of high carbon steel, but the difference is that it should be taken care that there is no other there are no other incident takes place. So obviously it is mainly used for carbon percentage, where the carbon percentage is with 0.3 to 0.6% carbon. Now, what is the process for flame hardening? The process is that, first of all, workpiece, that workpiece may be crankshaft or any other type of workpiece. That workpiece basically heated with a gas torch. That gas, already we discussed that gas torch basically used, that is oxyacetylene gas torch. Now workpiece is heated with oxyacetylene gas flame, and they will follow a water spray. So after heating, it is followed by water spray. Acts like quenching process. As we discussed in the quenching heat treatment process, basically quenching is basically heat treatment process where you have to heat the steel in austenitic region, then cooling, subsequent cooling with a cooling medium like water or any other cooling solutions. Okay, so as like same flame hardening. So first of all, heat it like in gas torch, where the gas torch basically used for oxyacetylene oxyacetylene gas torch, and followed by water spray, where, as you know that from the water quenching process, in water spray, after water spraying, that the phase that produced, that is basically martensite and bainite. Okay, and that when the martensite and bainite is formed in the outer surface of the periphery of the material, that basically case depth that can be, that phase basically produced in the outer surface of the periphery. Suppose this is the material, so up to 3 millimeter, suppose this is a 3 millimeter part of the outer surface of the periphery. So this is the part that in this part only martensite and bainite can be formed, but inner section is basically soft in nature. So this is important. This is a case depth, basically this the 3 millimeter can be achieved through flame hardening process. And after flame hardening, basically you can heating the material as like tempering process, heating the material around 200 degrees Celsius for stress relieving. Because of the quenching processes involved, because there are some temperature difference, so there are some stresses involved, some residual stress is introduced in the picture. So you can use heating the material again for up to 200 degrees Celsius for these purposes. Okay, so this is the flame hardening part. Now we can discuss induction hardening. Induction hardening also used in some cases, but in all the cases, in all basically in all the applications, basically four types of case hardening process are basically used. But induction hardening is also used in some applications. In this induction hardening process, it is also a case hardening process. In the induction hardening, that is basically used for electromagnetic induction. This is main working principle is that electromagnetic induction. You already know that what is electromagnetic induction. So for this principle, you can use induction hardening process. Now, basically the workpiece, that workpiece may be crankshaft, or you can see the carbon percentage, where the carbon percentage is basically 0.3 to 0.6 percentage of carbon. You can use there that induction hardening, that workpiece is enclosed in magnetic field of alternating current, where the alternating current passes through a magnetic field. That alternating current is basically with 10 kilohertz to 3 megahertz. So in this case, the workpiece is enclosed in magnetic field. Then after that induction process is completed, so after induction, the material is heated up to a certain limit, and after case hardening, that case depth that can you achieve, that is basically from 0.25 to 1.5 millimeter. Okay, and for in case of flame hardening case depth, that is basically used that 3 millimeter, and for this case, and this is basically 0.25 to 1.5 millimeter, you can achieve this. Okay, and it is basically after induction hardening, quenching process is needed, and that quenching process is basically done in the water state. Okay, and it is very fast process. Okay, now as we discussed in the previous all this topic like flame hardening, night hardening, cyanide, case carburizing, induction hardening, so these all are the basically one type of case hardening process. You already learned about that. Now one question to you, that what is the medium? Okay, what is the medium that used for cyanide process? Option 1 is charcoal. Option 2, that sodium cyanide. Option 3, that propane. Option 4, that electromagnetic induction process. What is the answer? Correct answer. I think that answer will be Right answer is sodium cyanide. So what is the medium that is used for cyaniding process? That is basically sodium cyanide. So thank you very much for listening and watching me. Goodbye.